A fisherman stands on a hill, staring at where his house used to be. There is nothing left but bare, swept earth. Minutes earlier, he had run. He did not look back, because looking back meant seeing the wave that was chasing him. The wall his town trusted to protect it was 10 meters tall. That's roughly the height of a 3-story building. The water that day rose higher than 15 meters. It simply climbed over the wall like it wasn't even there. Nearly 20,000 people did not survive that morning. An entire way of life vanished before lunchtime. Japan made a decision after that. Never again would a wall this short stand between its people and the sea. So Japan built something almost impossible to imagine, a concrete shield stretching 400 kilometers along its coastline. You could run 9 marathons back to back, one engineer put it, and still not reach the end of this wall. But would it be enough? To understand why Japan built a wall this massive, you have to go back to March 11th, 2011, off its northeast coast. A fault line deep under the Pacific Ocean ruptured. 2 huge slabs of the Earth's crust snapped violently against each other. In places, the seafloor thrust forward by an estimated 50 meters. That single motion shoved an unimaginable volume of ocean upward, a magnitude 9.0 earthquake. One of the 5 strongest ever recorded by modern instruments anywhere on the planet. The shaking alone was terrifying, but the earthquake was only the opening act of what was coming. Within half an hour, a wall of water raced toward the coast at the speed of a passenger jet. Coastal towns like Taro had prepared for this moment for generations. They had built seawalls to hold the line. Those walls had worked before, against smaller waves in 1896 and 1933. This time, the ocean did not play by the old rules. Raising a wall's height by even a few meters sounds simple. In practice, it meant rebuilding foundations, roads, harbors, and entire towns from scratch. Some experts argued for a different fix entirely. Stop rebuilding on the coast and move everyone to higher ground instead. Simple on paper. But fishing families could not run their boats from a mountaintop. Moving inland would end the only livelihood they had ever known. So Japan's engineers went looking for a third option. Not a taller version of the old wall, something built for a different kind of enemy. The old seawalls were designed to fully stop a tsunami, like a locked door. That single flaw had already been proven fatal. The new idea flipped the goal entirely. Don't promise to stop the wave. Promise instead to slow it down and buy people time. A wall that only slows a wave sounds like giving up. In reality, it was the more honest and more survivable engineering choice. Every extra minute a wall could buy meant more families reaching high ground before the water ever arrived at their doorstep. Government planners studied hundreds of miles of coastline, one stretch of beach and one seabed at a time. No 2 sections were the same. Some coastlines needed walls 15 meters tall, taller than a 5-story building. Others needed something entirely different beneath the surface. There is no such thing as a wall that stops every tsunami, one Japanese engineer warned. That single sentence would shape the entire project. Engineers modeled wave forces, seabed softness, and future sea level rise for every single kilometer before a shovel ever touched the ground. This wasn't one seawall. It would become 440 separate wall sections, engineered individually, then linked together like armor plates along the coast. The price tag for all of this came to roughly $12 billion, enough money to build well over 100 new hospitals. Construction crews moved into towns still scarred by wreckage. Building a wall here meant building around grief that hadn't yet healed.
All right, bring
now,
it to final position.
In fishing village
Lock the
after
clamps.
fishing village, giant
Roger
machine-powered
that. Pressure
jacks
stable at
push steel
5,000
forms
PSI.
into place along the shoreline. Engineers weren't just laying concrete on the surface. Foundations were driven down as deep as 25 meters, the height of an 8-story building. That depth mattered enormously. A wall standing on shallow ground could simply be undermined and washed away by the very water it was meant to block. Crews
All right,
reinforced
keep that steady.
every
We're ready
section
for the
with a
pour on
concrete
sector
skeleton,
4.
strengthened inside by thick
Copy
steel
that.
bars
Moving to
to
the
resist
next section
cracking
now.
under the wave's crushing pressure. Zero tolerance for defects. became the project's unofficial motto. On a wall this long, one weak section could undo everything else. Right now, divers are guiding massive concrete blocks into place underwater, forming a hidden foundation before a single visible wall rises above the surface.
Every stretch of coastline had its own seabed, its own currents, its own risks. Engineers couldn't copy one design and repeat it endlessly. Some communities pushed back hard. A 12-meter wall, taller than a house, would block their view of the sea they had always called home. One fisherman climbs the rising wall near his village, running his hand along fresh concrete, his expression torn between relief and quiet loss. For over a decade, this construction never really stopped. Crews worked section by section, town by town, along nearly 400 kilometers of coast. By the time the project neared completion, it had become one of the largest coastal construction efforts in modern history. So how does a wall like this actually work? Think of it less like a locked door and more like a giant speed bump for the ocean. A tsunami isn't one wave. It's a moving mountain of water, carrying enormous energy that must go somewhere when it hits land. The wall's thick, angled concrete face is built to absorb and break up that energy instead of taking the full hit head on. It will not make the ocean harmless, one engineer admitted plainly. It will only make the ocean slower. That slowdown matters more than it sounds. It can turn a wave that arrives in 8 minutes into one that arrives in 20. Those extra minutes are not just numbers. They are the difference between a family reaching high ground or not. Behind the main wall, deep foundations lock the whole structure into the seabed, stopping the base from being scoured out by rushing water. Gates and floodgates sit along harbor entrances, ready to seal fishing ports the moment a tsunami warning is triggered. Right now, sensors along the coast are constantly listening for the tremors and pressure changes that could signal another undersea rupture. When a real tsunami warning sounds, the response has to happen in seconds, not minutes. There is no time to think twice. The gate is closing. Alarms echo through the harbor as workers race to clear the water's edge before the barrier locks shut. In smaller tsunami events since construction, sections of the new wall have already held, giving coastal towns time to evacuate safely. We are not building something that can never fail, one project engineer said bluntly. We are building something that fails more slowly. That single sentence captures the entire philosophy behind 400 kilometers of concrete. Not a guarantee, but a fighting chance. Today, the wall stands nearly complete across Japan's northeast coast, linking hundreds of separate sections into one continuous barrier. For coastal residents, daily life has changed in a strange way. Many can no longer see the ocean from their own front doors. That trade-off remains deeply controversial. Some fishing families say the wall protects their lives, but quietly buries the sea that gave them their livelihood. Scientists studying past tsunamis found something reassuring, though. Coastal walls taller than 5 meters measurably reduce both deaths and building damage. Even so, researchers warn the wall alone is not the whole answer. Evacuation routes, warning systems, and public education still save the most lives. Some communities are now blending the concrete wall with rows of deep-rooted coastal trees, adding a second, living layer of defense. If we only build higher walls, one former mayor warned, we risk teaching people to trust concrete instead of trusting their own instincts to run. The fisherman from the beginning still lives near the coast. He has never fully returned to the water's edge, but he has not left either. 400 kilometers of concrete now stand between Japan and the sea. It is not a promise that the ocean will never return. It is a promise that next time there will be a little more time to run.